So first off, what are we dealing with? Traveling outwards from the Sun, we have Mercury, Venus, Earth, and Mars. After Mars comes the asteroid belt, a chaotic cluster made mostly of rock and metal. Then come the gas giants, Jupiter and Saturn, followed by the icy outer planets, Uranus and Neptune. Beyond Neptune lie trans-Neptunian objects, including things like comets, dust clouds, natural satellites, and dwarf planets like Eris and Pluto. Finally, and far beyond everything else, there's the Oort cloud, a theoretical cloud consisting of space dust and debris that marks the solar system's end. While experts firmly believe that this cloud exists, no direct observations have been made of it. It's just too far away, which is why technically it's theoretical. But just how far does our solar system spread? What would you have to do to reach its outer edges? And how long would it actually take? Luckily, we have a nifty little device called Voyager 1 offering up a major point of reference, traversing the outer reaches of the solar system as we speak. The Voyager 1 space probe was launched by NASA on September 5, 1977, and is currently still traveling at around 38,000 miles per hour. It reached Saturn, its primary target, in November 1980, but on August 25, 2012, nearly 35 years after its launch, it made even greater history by becoming the first spacecraft to enter the interstellar medium, a fancy term for the space between star systems in a galaxy. More specifically, Voyager 1 broke from the reach of the Sun's solar winds and entered into deep space. It's currently at a distance of 24.3 billion kilometers, or 15 billion miles from the Sun, and is so far away from us that it takes a radio signal traveling at the speed of light, roughly 22 hours to beam between the spacecraft and our home planet, all of which is pretty impressive. But while the monumental achievements of Voyager 1 should never be underestimated, we're still very far from making an even semi-significant dent into the solar system as a whole. It would take Voyager 1 another 300 years or so to reach just the inner edge of the interstellar Oort cloud, and up to 40,000 years to breach the cloud entirely and finally break free from the solar system completely. In truth, the solar system, and space in general, is just way too big for earthly measurements like miles and meters to really make sense. Instead, to measure distance in space, astronomers use something called an astronomical unit, with one unit equaling the average distance from Earth to the Sun, which is 150 million kilometers or 93 million miles. If you were to somehow drive a car to the Sun at highway speeds of 100 kilometers per hour, which is just over 60 miles per hour, then you'd eventually reach your destination in 1.5 million hours, or 171 years. Without some major technological breakthroughs, no one's surviving that. But let's say you splashed the cash, pulled some strings, and took the fastest air-breathing crewed aircraft in the world, the Lockheed SR-71 Blackbird. Traveling at constant top speed, it would now take you just 42,492 hours to reach the Sun, or just under 5 years. In contrast, definitely doable, although again, it's a journey that would definitely kill you. But let's be serious, because again, even the distance from Earth to the Sun is tiny when compared to the size of the entire solar system. So to answer the question at the top of this video, we need to set our sights much further out. Way out there is everyone's favorite dwarf planet, Pluto. Pluto ranges from 30 to 49 astronomical units away from the Sun. So at its average distance, it's almost 6 billion kilometers away, 3.7 billion miles. Light traveling from the Sun takes about 8 minutes to reach Earth, but it takes about 5.5 hours to reach Pluto. It's a long way away. And so, if driving a car at highway speeds, it would take you 6,850 years to get there. But as we've established, we still need to go further. The outer edges of the Oort cloud are about 100,000 astronomical units away, or about 1.87 light years, which is 17 trillion kilometers, or 9 trillion miles, give or take. And yet we still could go just a little further. Amazingly, the Sun's gravity can capture objects as far out as 2 light years away. This means that the very last parts of the Oort cloud could still theoretically be shaped by the Sun's gravity. By some measures, perhaps it isn't until we reach the halfway point between our Sun and the next nearest star, Proxima Centauri, that we've truly and incontestably left our system behind. So what does that all mean for our question? In straightforward astrological terms, we can say that it would take you nearly 2 years to reach the outer boundary of our solar system, if you were traveling at the speed of light. But of course, we can't do that. Let's hop back into our hypothetical space car then and go for the ultimate cruise. And you know what? Let's do one better. Let's skip the standard highway driving and up the stakes. Let's pretend that we're in the fastest street-legal car in the world, the Bugatti Chiron. And let's imagine we can travel at its max speed of 489 kilometers or 304 miles per hour. Heading for the Oort cloud, traveling at the top speed of the fastest car in the world. It would still be between 4 and 4.5 million years before you finished your trip. And that's without stopping for fuel or snacks. Now let's again pilot the fastest ever crewed aircraft, the Lockheed SR-71 Blackbird. The Blackbird's more than 7 times faster than the Chiron at top speed, so the trip does shorten. But it'd still take an eye-watering 550,000 years to reach the fabled finish line. Finally, let's say we hitched a ride on NASA's New Horizons probe, which left Earth at a staggering and then record-breaking 58,536 kilometers per hour, or 36,372 miles per hour. It took this probe 9 years to fly by Pluto. Again, when that happened, it was a monumental achievement that should in no way be overshadowed, but it still shows just how difficult it would be to travel any further. Even were New Horizons to have continued its unprecedented pace indefinitely, it still wouldn't have breached the Oort cloud for another 30,000 years or more. That's 30 whole millennia for a relatively tiny vehicle that could never carry a pilot. Even if we throw all physical sense by the wayside then, it's still an almost incomprehensible journey. For now, what are the things we know? First, how long it takes to travel the solar system depends entirely on what you want to travel in. In just your standard supercar, 4.5 million years. In a high-spec aircraft, 550,000 years. On a state-of-the-art NASA probe, 30,000. Even if you could somehow move at the speed of light itself, it would take almost 2 years to get from A to B. But 1, that's impossible, and 2, that's cheating. Short of building wormholes, this just isn't a trip that will ever be done quickly. No matter how you travel, you'd be long dead and space dust, way before you'd even considered getting even relatively close to even the inner edges of the Oort cloud. And remember, no matter how daunting the solar system may seem when viewed in this way, it's actually very small in the wider view. It's just one small speck in the Milky Way galaxy, which is but a tiny grain in the grand scheme of the entire universe. So next time you're complaining about your regular daily commute, remember this video and relax.